Hey, good morning, everybody. This is Mr. Aynesworth. We're going to get into your Chapter 1 project, Part 2, that we're going to go through here. We've already been through Chapter 1, and we are going to put it all together in Chapter 1, Project Part 2. And in this case, we're going to be working on how to find standard deviation step by step and get a feel of what the computer has to go through in terms of the numerical computation of what's involved. But thank God we're not going to be doing this, by hand. We're going to be using Desmos here to do all our work for us, and it's going to be similar to an experience if you ever used Excel. These are the same type of things used in Excel, but I'm using Desmos as our calculator tool to help us do all the computation here. So what we need to do first is to log into your Desmos account. And if you haven't done that, like I have here, is you got to log in. If you don't have an account, you got to sign up and put in your email and sign up and get an account, because you are going to save your work as you go. Now, to do this, you're going to start off with a new blank project here, and then of course you hit save, and then you put in a title like Chapter 1 Project Part 2 with your name on it. Okay, so do that first. Okay, I'm going to pull up the project that I already have started here to demonstrate on. So make sure you save all your work, because you're going to be submitting this in Canvas, where you submit all your assignments. So the first thing we need to do is you need to put in your data table. And in this problem here, we've got some research done on shoe sizes. Okay, you survey 30 friends, and just read at the top here, to get their shoe sizes in centimeters to avoid differences between men and women's sizes. And we have the following data here, and there's a sample of 30 people here with their shoe sizes in centimeters, and what we want to do is calculate the variance and standard deviation of these shoe sizes, but not using the Desmos command, which you can do in seconds. Seriously, it's extremely simple, but we want to figure out how to calculate this by hand, step by step, by calculating the deviation, the absolute deviation, square deviation, and etc. So I'm going to take you through how you use Desmos effectively, not by direct computation, but by writing formulas instead of direct calculation. Okay, so that's what we want to do, is we want to learn how to use formulas to do all the computation. All right, so let's get started here. So first of all, you got to put your data in. If you don't have your data in, what you do is you go onto an available row. Okay, obviously I've already done it, but if you haven't, so what you do is you click on the plus sign and you select table and you put in your data. All right, starting with the student, like 1 through 30. So you go 1, enter, 2, enter, 3, enter, and you go all the way to 30. Okay, you can do that on your own, and then go up here to Y, the second column here, and put in your shoe sizes, starting on the first one, right, at 23.8 and so on. Hit the enter button, and it just shifts down, and you can enter in the data. I'm talking about this data right here pretty easily. And just make sure you hit save, throughout your project. Okay, so you can do that. So pause the video right now and do that, and then when you're ready, go ahead and hit play. But I'm going to delete this right now because I already have my data in. Okay, so pause the video right now and get your data in. All right, I'm going to assume that you have your data. Sorry about that, it's my dogs. I am assuming you have your data in. The first thing we want to do is calculate the sum of all your data. And we're talking, my data is in Y1 because I called it Y1 up here. So I'll go to my next available row, and I type in, not sum, okay, but the word total. Now, you can go to functions, and you could go to stats. Okay, there's 4 menus up here. You can go to stats and then click total, and then type in Y1 because your data is in Y1. Or you can do it the easy, or another way, you can just type total. Whenever you want to sum, it's obviously a total. But you got to tell the Desmos where the data is, and the data is in Y1. So let's take the total of Y1. So you got to use some common sense here. And notice that the total is 767.6. So let's record that over here. So on your project, write down total, and that's 767.6. All right, pretty simple, right? Okay, so now what we need to do is calculate the mean, and the mean is the total, x bar, the mean is equal to the total, all right, divided by the number of data, which in this case is 30, right? It's 30 pieces of data, and so you always take the total divided by 30. Okay, so we'll do this 2 different ways. So what we're going to do is copy this right here, just go Control C, go down here, Control V, and then divide it by 30, and then voila, you got the mean. Okay, now the mean can also be found by typing in the word mean of y1. So you can do it this way too, and notice you get the same value. The mean function is also up here. It's in the stats menu. Okay, mean, which is average, same thing. And so you can get it multiple different ways. If you're a good typist, just type in the word. Okay, if you want a total, type in total. If you want mean, you type in mean. Hit save, throughout your project. So now the mean is 25.586 repeating. So 20 x bar, or the mean. And the mean, you guys used mu earlier on our previous work here. That's the same thing as x bar in this case. All right, it's 25.586 repeating. 586 repeating. You can round it to 587 if you want. So we got the first two things here. So far, pretty simple, straightforward. So now what we want to do is we want to go to the next column, and we want to develop this data right here. And this is called the deviation, which is the distance from the mean. So distance from the mean. Okay, that's what deviation is. When you subtract the score, or the mean from the score, or in other words, score minus mean, right? Remember, x bar is mean. All right, you get the distance from the mean. So if the score is greater than the mean, well, it's going to be positive. If it's less than the mean, it's going to be negative. You guys should know that. So what we want to do is type a formula for that. And we don't use numbers here. We don't type in numbers. We type in formulas and let Desmos do the work. Now our data is in y1, so I'm going to type in y1, and then I'm going to subtract the mean. And so what I need is a formula for the mean, and it's right here. Now I can type in mean of y1, or I can use the total of y1 divided by 30. Whatever your choice. If I select the mean of y1, just copy it. Okay, and go back up here and subtract the mean. So when you paste that in, you go Control V. So I copy paste all the time in formulas because it's useful. And so notice that I have y1 minus the mean of y1. All right, because the date is in the second column, which is labeled y1. All right, so you have to understand what the formula is all about. It means take the value, the x values in your table here. Let me just enlarge this here. All right, there we go. All right, the x values, and subtract the mean. Remember, this x bar is the mean. So x minus the mean. In my values, okay, in my table, I have the values in y1, so I got to go the mean, or excuse me, y1 minus the mean of y1. Okay, sorry for the interruption there. Okay, so now we have the deviations, okay, and all these numbers represent the distance from the mean. Some are negative, some are positive, as you can see right here, because if you're less than the mean, the difference or the deviation is negative. If you're positive, that means you're a bit just bigger than the mean, right? Okay, so now we need to go to the next column, right? The next column is the absolute value of the deviation. So on the bottom right here, there's an absolute value symbol. So you type that in, and then you copy the formula, okay? You don't type in the numbers, you copy the formula. So what you do is you go over here to this column, you select it or highlight it, and you go Control C for copy, and you go over here in the absolute value and you paste it in, which is Control V. And notice that, like in the first in the first row right here, negative 1.786 repeating becomes 1.786 repeating, because the absolute value of a negative is a positive. All right, pretty straightforward, I think, so far. So now let's continue here. So the next one, the next column, is the square deviation. So you got to take your deviation, which is in the third column, and square it. No big deal. So what you do again, you highlight the formula. Okay, you don't type in values, guys. You highlight the formula and copy it, which is Control C. Then you go into the next column right here, and you type in their parentheses. All right, and you paste it in, Control V, and you close off the parentheses, and then you square it. And then go down here, and you see that A squared button? That's your squaring button. Or you can go Shift 6, which is your caret symbol on your keyboard there, and you can take it to the second power. Either way. And notice that it squares the values. So if you take negative 1.786 7, 8, 6 repeating and square it, you get 3.19 something. Okay, and so you get all the values squared. And notice it does all the work for you. And this was part of the intent of the project here. You guys were supposed to use your creativity on Desmos and learn Desmos well enough so you can generate all these values. And I'm not going to take and recreate or write down all these values. You guys can do that. But basically what you want to do is take these values, right, and then put them over here. And obviously you got to round them a little bit, right? And you guys can do that. That's no big deal. All right, so you just put your values in your table. All right, piece of cake. So let's go back here. So now what we want to do is we want to calculate this deviation sum. So let's start calculating all these sums right here. And the sums are easy. So let's figure out how to take the sum of the deviations, okay, which is called obviously the deviation sum, which means you just add up these numbers. Okay, hang on, let me just change something here. There we go, that looks a little bit better. Okay, oops. Hang on, let me just adjust something. There we go. And, oh, there we go. Okay, so we want to take this right here. Sorry, I'm just adjusting things so it looks a little bit better for you guys. Okay. So we want to take our deviations, and which is this column right here. So this is going to be, this is x minus x bar. This is the deviation sum. And we want to square these guys. So that's easy to do. So you just select all these values. So what we want to do is total these values up. So you go up to the top where your formula is and copy it. Okay, go down to the next available row in Desmos. All right, and you type in total, right? Because I told you earlier that total is the same thing as sum. And you paste your formula in, and boom, it tells you what you get. Okay, now this is a weird number, I know. Now, some of you guys are getting this too, and you have to understand that. Just a second here. Okay, sorry for the interruption there. That this number here, let me copy it here. This is scientific notation for a very, 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 very small number, like 0. Okay, so some of you guys are getting this, and what happens is that in every computer there's a little bit of rounding error. Okay, so when that happens, you just have to understand what you're doing here. This right here is equal to 0.000. There's 13 zeros here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oops, that's one too many. 13 and 3, 1, 9, 7, 4. And you got the idea. This is a very, very, very small number. Okay? And what this is equal to is 0. So the deviation sum should always be 0. Okay? Write down always 0 here. Always equal to 0. Okay, there's a proof of that, by the way. Okay, and I talked about that in class, but so just accept that if you weren't here in class, like some of you guys are in quarantine, then just understand that the deviation sum is always 0. And then when you take the mean of the deviation, that's 1/30th times 0. Well, that's 0 divided by 30. Okay, and that's still the 0. So we should get 0 here, and we basically did. There's just a little bit of rounding error in every computer. Believe it or not, they're not perfect. And this is right here is just a way that the computer is showing that it's 0. Believe it or not. Okay, and then what do we do? What do we have? So we got to find the absolute deviation sum. So let's go ahead and do that. Let's go back up to the top here, and let's go to the next column. Okay, so now what we need to do, I'm sorry, we got to calculate, what do we got to calculate here? Oh, okay, I'm sorry, so we got to calculate the square deviation here. So what we need to do is take the square of the deviation. So what I'm going to do is type in parentheses here. Okay, I'm back now, and I apologize for the interruptions of my animals here. My dogs were running around. But let's see if we can reconvene here and continue this here without any more interruptions. So once again, I apologize. When you get the absolute deviation sum, all right, so what I'm going to do is I'm going to copy this formula that I wrote for the absolute deviation, copy it, Control C, and you go down here to the next line and you type in total, all right? Parentheses, and then paste it in, and it'll give you the total or the sum of the absolute deviation, which is 43.8. So this one right here is 43.8. Now to get the mean, well, you just copy the formula, right, and divide it by 30. So copy this formula, go down here, and then divide it by 30. It's that simple. And it's 1.46, so this is 1.46. All right, now to get the square deviation sum, you got to go back up to your formulas. So you copy the formula. Again, you don't do all this by hand, guys. Control C to copy it, go down to your next available row in Desmos. All right, and you want to sum it. So you type in total, as I keep on saying. And you type in, or you paste it in, and it tells you that the total deviation sum is 96.19. So 96.19. The variance, you got to multiply that by 1/30th, which means you got to take that and divide it by 30. So once again, you copy this formula, go down to the next line, paste it, divide it by 30. Okay, and there's your variance. So 3.206. 3.206. There's your variance. Now to get the standard deviation, you got to take the square root of it. So go down to the next line, click on the square root. Okay. Well, copy the formula above first, okay, and then let me repeat that. So you copy the formula, the variance. Again, you don't type in numbers, guys. You type in formulas, all right, and then you click on square root. You paste in your formula, and it tells you that the standard deviation is 1.79, which is very accurate. Now to check that, okay, you click on functions, click on standard deviation of the population. You type in Y1, and notice you get the same result. So there's your check, okay? Make sure you pick the standard deviation that ends with a P and not the other one, because it's the population standard deviation, not the sample. And there you go. And that's how you do the whole project on Desmos, all right, by writing formulas. So again, you write formulas instead of computation. That's the key, all right? And so let's put that in red right here, okay? Write formulas. All right, instead of computing every single value. All right, and then you just get used to it. And these ideas, believe it or not, are useful in Desmos, because Desmos, you do the same thing. You don't computate and then round. Okay, there's no rounding. Let's write that down too, no rounding. Okay, you don't type in the numbers, all right, and round and use rounded values, okay? You use formulas instead of rounding. And notice that I didn't type in numbers here. I didn't use a rounded number like the mean was 25.59 roughly, or 25.6. If you rounded this number and used 25.6, you would have created a lot of error in this project. And a lot of you had that happen to you. Your standard deviation when you're done was not even close to 1.79. Again, this is our goal. Our goal in our project was this right here, the standard deviation. All right, this last one right here. And because you guys rounded the first number, the mean right here, which was about 25.6, you rounded to the nearest tenth, and you used the rounded answer throughout your project. It threw the entire end result off, because once you take a number that's been rounded, it has error. And then you subtract, you get all the deviations which have error, and then instead of getting exact numbers, all right, you have numbers that have a lot of error involved. And then you square the numbers that have error involved in the third, the last column here, the square deviation column. And if you do that, my friends, okay, you get even more error. So the error propagates. And by the time you get to the done in the last result, the end result is so far off the actual, it's not even funny. So you don't want to round, you want to use formulas, and that's the key. All right, so once again, when you're done with the project here, all you do is click on this share button right here. Don't share the link. All right, save it as a PDF. Instead of printing here to paper, you select Save as PDF, and then of course you save it, put it in your Google Drive where your financial folder is, and you can upload it to Canvas from there. Okay, should be pretty easy to do by now. So there we go. That's the entire Desmos part of the project. The next part, in the next video, I do it all in Excel. Okay, and I show you guys how to do it all in Excel and get the same values using formulas. Okay, so if you haven't done that part of the project yet, do that. That's coming up. That's the next video. All right, this one was all about using Desmos properly to generate all this. The next one's using Excel, or what's called Google Sheets if you're online. All right, this is Mr. Aynesworth. I'll see you guys later, and hopefully those in quarantine come back very soon. All right, and I apologize for all the interruptions with my puppies. Okay, I have a lot of animals at my house, and they were goofing around, so being like kids, I guess. So I'll see you in class. Take care. Bye-bye.